All right. Hello, everybody. Welcome to my live stream. So this is the Computer Vision Power Hour. This is where we spend an hour doing computer vision stuff, teaching computer vision, all kinds of fun. Today I didn't have anything really big planned, but I kind of got an idea this morning that we're going to try out. This is something that I haven't tried before, but we're going to use a library that detects faces and blurs them, hopefully. So that's what we're going to try to do today, and I will bring up the screen right there, and we are ready to go. So last week, just as kind of a reminder here, if you weren't here last week, here's what we did. So last week we created a model in PyTorch to detect pedestrians, and I'll just bring it up here to show it. Oh. Better activate my environment here. Python main PLI. So we did a lot of work on this thing, kind of putting things together. Oops, and I don't know why this comes up over here now, but here we go. So we did a lot of work last week trying to count pedestrians, trying to do pre-processing of images before they go into this model, but we created a PyTorch model. I shouldn't say we created one, we're using one, a pre-trained model, but we created a connection, we got it dialed in to where it will count pedestrians in a live video. We streamed this video in, we wired up the PyTorch to it, and it works pretty well. As you can see here, it's counting 86 pedestrians in Times Square, which is great. And today I just kind of wanted to do something a little bit different and try to make it detect faces. Obviously, we're not going to be able to do that with this particular stream, but we have multiple streams. We found one down in Florida that's kind of neat that does show people's faces. So I think that will help us out a lot.
10 failed.
And I'm going to do a quick tech check here just to make sure we're on where we're supposed to be on. So today I'm streaming on YouTube, couple few different places. YouTube, Facebook, and Twitch. There we go, make sure that is selected. Yeah, I'll just do a quick tech check here really quick. And it looks like I am live. YouTube? Yep, we're here on YouTube. We're here on Facebook. Perfect. That is what I wanted. So I will be monitoring the chat if you have any questions. The chat is open, wide open for the questions that we're doing here. Now, we have here, also to recap, so we got this pre-trained model to detect pedestrians. It's PyTorch model. We wired into it with this Python script. We used OpenCV and the stream something library to load in a live camera. We're processing it frame by frame, running it against that PyTorch model, drawing a little rectangle around each of the pedestrians we identify, and it works pretty good. This one here is kind of like a pretty difficult level, I would say, because of how small the pedestrians are, how busy this image is. This is actually a pretty difficult thing to try to pull off. So we got it going pretty good. There's a lot of pedestrians there that aren't being picked up, but we're cool with it. So I found this other library. See, I'll close this window. This is our other window. I'm trying to find it now. There it is. Now this library is just called Face Recognition. Very popular library. I have used it before a while back, but a couple years ago, but nothing recently. And I found this thing that was kind of cool, blur faces on webcam. And I thought, this might be something kind of cool to wire into our existing project and see if we can identify faces and blur them using this library and using this example code. But first, we will have to go to a different webcam because you're not going to find faces on this one at all. Except maybe Pepe Gamez here. But we're not going to find faces on any of these smaller ones. So we're going to go down to that Key West feed. Here it is, Duval Street in Key West. Let's load that up and see how many folks are in Key West right now. I imagine it's probably a nice day. It's like 2 o'clock in the afternoon. Should be some people out there. And this keeps popping up. So I think we might be able to get faces from this one when someone's like walking on the sidewalk or something like that. So this one might be worth using for this. If not, we'll find some other video. One thing I haven't tried with this exact script is just a YouTube video, just pumping in a YouTube video. Maybe we should do that really quick just to see. YouTube.com. Maybe we'll just try. Here's the Bryant Park webcam. This one we might be able to get faces off of. This is one that we look at a lot. The Venice Beach live camera. Clearly this thing is throwing a bunch of webcams my way. Let's just look for pedestrians walking and see if we can find like a video. I guess this one, any video pretty much should do. And we're just going to see if this will stream the same as a live video. YouTube URL. Because I haven't tried it on this exact script. Should work, I would think. We'll see. Negative. This does not appear to be working very well. And this could be because we're going for the best model. I don't know, but this thing's really slow. It is detecting pedestrians, sort of, right? Oh, I see, it's faded in black. That's why it looks so weird. But it is really choppy and slow for some reason. That is another one of those things that we need to work on. We need to figure out how to stream this video faster. I mean, I know we're processing it frame by frame, but it should go faster than this. So yeah, it's pedestrian detection is running on this video, although the video is going very slowly. I might be able to speed it up by resizing it. Who knows? Worth a try, right? Some of these, and I talked about this a little bit in our last stream, some of these computer vision projects, people resize videos and images down very small for object detection. We're going to say 400. We're going to go really small with this and see if it just kind of speeds it up a little bit. It might. I don't know. Once again, we're starting in the black, and it looks like it's still really slow. Oh, and there is something that I need to change before 11 o'clock on a different Twitch channel. So bear with me really quick while we quit this, because this video is too slow. Let's bring up Times Square again at like 900. See if the Times Square is actually faster while I go and update some things here. Sorry, I gotta grab a description here. So I'm assuming David Neal's going to be doing his live stream on Pluralsight. So I want to make sure his all right, there we go. Hello, XLNC1807. Welcome to the chat once again. And today we're going to try to detect faces and blur faces. Yeah, this is a little bit of progress. Mostly, this pedestrian counter, mostly what helped with this, I think, is brightening up this image. We brightened up this image, sharpened it a little bit, and it seems to feed into that model just a little bit better, I think. And today I think we're going to go back to Duval Street and we're going to spy on those people in Key West, because I think here we can grab some more faces, some better faces than the Times Square one. I don't think we can get any faces off of that. But this one, we can see people. This is outside of Sloppy Joe's in Key West. We're going to leave the pedestrian detection in there also and try to put the face detection over the top of it, which may be a little wild, but we're going to give it a try. So we tried a regular video. It was okay. So here we have face recognition. We'll do a pip install of face recognition. Face underscore recognition. And we get a whole bunch of requirement already satisfied. So, okay. So everything we needed for face recognition is there. Let's look at this code a little bit. This one's using a video capture, and then we need to initialize some variables. So we'll do that. We're just going to rip this code out of this example and see if it'll work in ours. Actually, we'll put this in main. So we have process frame. We'll collapse our functions here, and we'll just put this in main right down here. Face locations. And then here, they're grabbing a frame, resizing the frame. As you can see, we're resizing it to 1/4 of the size, which we might try that too. I mean, why not? It's in here. We can resize our existing frame, which is right here. It's frame. We have original frame. That one's being resized. Let's create a small frame just for this stuff. Then find all the faces and face encodings in the current frame of the video. So we'll do that. This is not processed. So we may take, you know how we have the two images, so we have the pre-processed, what we're sending to the model, and then the visual image that we can visualize on our own. We may use that for now. Face recognition, better include that. But we may take that one that we're passing in the model that's grayscaled and contrast and all that stuff and use that for this frame too. We don't know yet. So now we have face locations. And here we can say display results. And we want to display this on, I think we're going to display this on the main frame. We're going to put both of these together because we're just wild and crazy like that, right? But let's see, display the results. And I feel like I need to put in something like start face stuff, end face stuff. Put all that code in here so that we have it kind of separate. Start face stuff. We'll put all the face stuff together. Remove all those tabs. If this works on the first try, well, when the stream's over, we're done. We did what we said we're going to do, right? Now we'll fine tune for sure. It's going to do all of this stuff. Put the blurred version back onto the frame image. Blur the face image. Put it back on the frame image. So then it looks like frame will be what we're going to display in a window. So we'll have yet another window, I guess. We'll call this faces. Oops. Let's see what this one looks like when we run it. Oh, nope. Open. It's having a little problem here. Face landmarks, face encodings. Face locations. Small frame is taking the original frame. We'll go all the way to the top. Yeah, I like errors. I didn't think it was going to run the first time and work, but it would have been wild if it did, right? So it starts line 8. An error with importing face recognition. So it doesn't even like to import face recognition. Maybe we should make a copy of this. And actually, I want to use a better terminal than this. So I'll go here to People Finder. Now I've got another little terminal here. Running our test here to make sure GPU is supported. GPU is supported in both PyCharm, both PyTorch and OpenCV. So that's awesome. Python main.py. This way I can get a little bit better view of this error. I do have PyCharm. I don't think I have it installed on here, but PyCharm is pretty sweet. Uninstall and reinstall again here. Figure out why this is happening. It's happening with import site packages. Does not like it. Line 4, import dlib. We already have dlib installed. It just does not like to install. LibVidStab, some silly video library. Let's see. So we're reinstalling SSL module. But I am not in Ubuntu, so see if this is something. Nope. See if I can find what this library is and install it, hopefully. This vid.stab. Let's just see if I can install it. It's probably going to lead us down this wild path, right? Oh, maybe not. Okay, now we have the library. Still cannot open it. Video stabilization library. Let's try. Again, we'll uninstall face recognition and reinstall it. Now that we have this library. Not open. This could be an older version. Yeah, this one's 1.2.1. So I wonder if I can install an older one. I've been having a ton of problems with FFmpeg, and I have a feeling this might be an FFmpeg thing. I have had just a ton of problems with it because a certain version is required to run OBS on here with web stuff, which I need to put the chat on the screen, which I might just remove the chat from the screen at some point. But yeah, so I have this weird FFmpeg, and it just causes problems all over the place. Here's our file list. And it's 1.2. So that's probably part of our problem. This is one of the lovely things about running Arch Linux. Just lovely things is libraries are kind of a mess sometimes. Stuff like this is kind of a mess. So yeah, that's 1.2. I need 1.1. How can I do this? Wonder if I could just download the RPM and run it. Just totally break it. Changes, no changes. Downgrading packages. I haven't done this for a long time, but I don't want to downgrade too much. I don't want to downgrade all my packages. Maybe I can find something in the AUR. Did stab AUR. Stupid FFmpeg. I hate FFmpeg so much. Without this library, I may not be able to do what I set out to do today. Let's see what we have in mirrors. See, it says 1.1.1.1, so it's like, I don't know. If I could just download this from somewhere else. I probably need to rebuild FFmpeg, which I really don't want to do. Rebuild it with this library here. So now I got to remember which FFmpeg I used. Probably FFmpeg OBS. Probably not smart to do while I'm using OBS, but we'll see. Just let this thing build for a little bit. Maybe if I build it with this library included, rebuild it, it'll be good and awesome and cool. We'll see. I might try breaking this out into its own, like just taking that whole example and breaking it out into its own thing, right? Take this entire script here. And running it. Failure occurred. Yeah, I'm gonna mess with this stupid crap. We'll go back into our people finder. Let's do face.py. And face.py definitely will not work without that silly library. I'm gonna try creating a whole new Python environment and try building everything from there. See if that helps. So we're gonna do python-m venv. We're gonna call this one face test. Deactivate source face test bin activate. How did I end up in repos? Who knows? Okay, so we need to do pip install face recognition again. We'll need to install OpenCV, I'm sure. But maybe rebuilding this environment from scratch might help us a little bit. That's what I'm hoping for. We shall see. This sure has taken a lot longer, so it's possible. And then we'll probably have to install OpenCV, Python, and Streamlink maybe. Yeah, it's taking a lot longer than before, huh? Good sign? Kinda? Ish? Good-ish sign? And of course we need to do pip install upgrade pip. Still no go. It's just the video stabilization part that for some reason this face recognition library requires. Now here, grab a single frame of video. Required if you want to run the specific demo. I mean, I don't know why the visuals, this is one of the things that I'm kind of puzzled about, is I don't know why the face recognition library would require this video stabilization if we're handling the video somewhere else. I mean, we can do this with a single frame, right? Theoretically. Let's check out some more examples here. Face rec from webcam, face rec from webcam faster. Multiprocessing. Check on Raspberry Pi. Recognizing Biden and Obama. Identify and draw boxes on faces. Let's clone this and run some of these demos and see. Just gonna jump out of here really quick. And I'm just gonna use Vim so that we have our Visual Studio Code one open for our other project. Where did we clone this? Face recognition. And let's create another environment here. We'll go to examples. Identify and draw boxes on faces. Pip install. Face recognition. Let's just try it without any video involved and see, but maybe that video stabilization library just has to be included in the face recognition library, and if so, then let's figure out how to do that. And I might just remove the chat from my screen and install a different version of OBS so that I can use different versions of FFmpeg. And yeah, FFmpeg has been heck of a pain in the butt. First time chatter. Fahe8 says, hello Morgan. Are current AI models able to detect any kind of object in the real world? For the most part, yes. It depends on the objects that they're trained on, but as long as you are training them with the object you're looking for, then yeah, ostensibly pretty much any object you can think of, it can detect. There are a lot of different variables, like we're detecting pedestrians in Times Square, for instance. It's very difficult because the camera is very small and the people are very small. But what types of things are you wanting to detect? I should ask, because they make this stuff. It's upgrade. They make this stuff look for everything. Cancer cells. Static object, definitely. That's definitely something that OpenCV can do that really well with just basic like classifiers and stuff. When you throw PyTorch into the mix, it gets even better. Like PyTorch and their pre-trained models are even better. Python, identify and draw boxes on faces. We're running into the exact same problem. So I don't think I can use this library, unfortunately. Let's go back to our main project here. I thought this would be pretty cool, but this face recognition library is not going to work on my machine. And hey, since you just joined, I'll show you what we're working on. What we're adding to, I should say. And we'll comment all this stuff out for now. Not entirely ready to give up on this, but kinda. There we go. Now I think we're back where we need to be. Comment all this stuff out. You perhaps know if there's glasses which implement such AI. I've heard rumors. So here's what we've been working on lately. Pedestrian detection. I don't know that there are any glasses right now that are doing this for sure, but I have heard that the Google Glass project is kind of restarting, like they're doing another version of Google Glass. And Google Glass did do that. And there's a lot of AR applications out there, tons of AR applications that are using computer vision to detect objects and things like that. And so I probably am just not aware of how many are out there, but let's look it up. Let's see. Machine learning on smart glasses is the top one. AR smart glasses to merge with AI, computer vision. Geez, tons of ads on here, huh? Close. TensorMark, whose AI and computer vision technology has applications developed, blah, blah, blah. They are working on something called the Vuzix Blade smart glasses. So this uses an onboard camera, and it looks like it uses cloud-based AI and computer vision and more specifically, facial and object recognition. So I guess the answer is yes. I don't know if these have been released yet. When was this article written? 2020. They might have been released yet. Yeah, no problem. Let's see if they have been. Vuzix Blade smart glasses. With certified app. And $1,000. Whew. Yikes. I was just thinking, maybe I should pick up a pair of these glasses if they exist, but $1,000. Yikes. And they're out of stock. It says on back order. But let's see what these glasses have here. Autofocus HD camera. They have integrated stereo speakers, full color display, UV protection, wireless Wi-Fi and Bluetooth, but it doesn't say anything. Oh, the false boxes. There's a lot of false positives, especially in this particular image. And most of that is just we need to process the model a little bit, or process the images a little bit better before going into the model, and then additional training on the model. So I'm using a pre-trained model that's pretty basic, and it could use some retraining for sure. And if we were going to do this for a specific purpose, then we could flag all of these false positives and retrain the model and say, don't look at this, don't look at this. Like it picks up a street lamp post off the street. We could say, we don't want to pick up this. And with constant training, like if you have a very specific application, with additional model training, you could definitely remove a lot of these false positives. Like some of these pedestrians are not pedestrians. And this thing is going really slow. I'm going to turn off that extra frame here. Pop this back up. Got the idea to create such kind of glasses to assist people in passive learning the local language of a foreign country. That would be really cool. For example, if you're walking around and seeing a lot of Japanese characters, and then have character recognition, and that would be really cool. I don't travel outside the country hardly at all, but if I did, that would be something I think would be really interesting, to look at signs in another language and have it translate for you. That would be Amazing. Uh, if you could get that working, I think that would be a hot selling item. I would look into those glasses, even though at $1,000 a piece, you'd have to buy those and then put your software on it. Whew. You give me a free pair. Thank you. Yeah, $1,000 is a lot of money, especially for a pair of glasses. But I would say that would be something that people would be very interested in, especially world travelers. You know, or if you're somebody, say you live in the United States and speak English and you married somebody from France, and you're traveling there a lot and visiting family and things like that, as you're learning the French language, those glasses would be invaluable. You could walk up and, you know, read things on signs and things like that. That would be cool. I have read a little bit about real-time translation for audio stuff with AI that's getting really advanced. Yeah, production costs are justified at $1,000. Yeah, that's a lot of money because your product you'd have to add value to the product and then sell it for obviously more than $1,000. Which prices out a lot of people. Really, I mean, it prices me out for sure, but it prices out a lot of people. If you say, well, we have these glasses that do this and they're $2,000, like, yikes. Not fun. So I still don't really want to give up on this face recognition library. Like I said, I've used it before. It's a great library. It's an awesome library. But it just does not want to run without that LibBibStab. I was hoping I could just download that somewhere. So Arch Linux installs it, but it installs 1.2. There has to be another way to do this. Let's tab SO. Yeah, it does 1.2-64. So what if we did 1.1-64 as the file name? Oh. That's supposedly. Supposedly it's included in that library, but we're not able to find it. And here's the problem that I'm having. Somebody else is having it right here. So I think I'm going to have to do, what am I trying to achieve by blurring images? Oh, so what I want to do, I didn't even realize this thing is still running over here. So what I want to do is see, like right here, you can see this gentleman's face. I want to detect the face and blur it for like privacy purposes. Would be one, that's one use case I could think of that would be good for this, is just like privacy. Where if you had a live cam like this that you're displaying and you want to show it to the world like these folks are, this is outside of Sloppy Joe's and they're just putting it on there. Well, maybe some of these people don't want to be on here. You could blur it just for privacy reasons. I could definitely see some good uses for that just for privacy purposes. Or maybe you record an event. Not everybody at that event wants to be seen. That'd be a good way to do it. You could just kind of blur out their faces, and I don't know, it seems like it'd be kind of cool. And I'm mostly just doing it today for educational purposes so that we can see what's possible and what we can do. Vid.stab. It's up to date, reinstalling. Yes, we reinstall it. Maybe it's a DLive thing. We can look that up really quick. See if there's a DLive package that might work. DLive Python, Arch Linux. Are you creating this for a customer or just studying purposes? This is just studying and learning. So this computer vision power hour is basically where I just spend an hour teaching computer vision stuff. We've covered a lot of stuff in here with object detection, image manipulation, things like that. And yeah, all of this stuff is just for fun, basically, and learning. So don't have any customer for this yet. I do have a project possibly coming up, but I don't know if I'll stream it or not. Oh, not pip. Sudo pacman-s. We're going to install Python DLive for Arch Linux. That's what I was looking for, right? But yeah, this is all just for learning and fun. Oh, this is an AUR package. Okay. So for instance, I'm showing folks how to use Arch Linux also on here. This is just an educational for fun type stream. We're going to install Python DLive. Because it is possible that it's just we need to rebuild this and make this connection here. But yeah, everything we do on here is for fun, basically. Fun and education. And it's been educational. We've had some very interesting problems on here that have been really fun to solve. I need to check something here really quick. See if my friend David Neal is streaming. He is streaming today. Very cool. So one of the things that we're going to do, I'm going to try this thing and get it running. But one of the things we will do is go visit my friend David Neal, who's building a JavaScript game here pretty soon. And that'll be pretty cool. Pretty fun. I don't know if you can hear it over the microphone, but my computer is ramping up pretty good. Fans are ramping up. Yes. All right, now we have DLive installed. Still doing it. What changes you made in the pedestrian detection to make it accurate? That is a great question. I will show you. So what we did last week, let me bring this video up so you can see it, is we built in the model and then made some changes. And so what I wanted to do is show the processed version, and this is like the human watchable version, and then I wanted to display what we're passing into the model. So some of the things that we did here, you can see we made it grayscale for one, so that it, when it's grayscale, it basically processes. So instead of 3 channels trying to process 3 channels at the same time, like red, green, and blue, we are just processing one grayscale channel. We resized it so it processes a little faster, and then we've added some contrast, some brightness, things like that, a little bit of blur. We played with blur kind of a little bit to make that a little more accurate. And all of these changes kind of prepared the image before it goes to the model in order to make it more accurate. So with this, we can, actually, we'll go to the Times Square one really quick. And you can actually kind of see it in real time as we mess with it. So bring this up again. 72 pedestrians. We can add some blur to this and decrease the amount that it sees. So we sharpen it, we blur it, all this kind of stuff. Here we go, in process frame. Like we can do erosion. And erosion is one of the things that you want to do for object detection. If you're detecting a big object, eroding it down is definitely one of the things that helps. Let's see, for some reason I cannot grab, there we go. And actually this amount of erosion didn't really affect, but as you can see, this is the image that we're passing into the model. And erosion is almost like a blur where it merges different pixels together, but it doesn't seem to have affected, erosion doesn't seem to affect it negatively. And now we see, this sounds too ambitious and maybe even impossible at the moment, but my long-term goals with the mentioned technology are to achieve a singularity between human and AI to improve the human's abilities, which is awesome. That's like the best usage of AI and why you'd want to use AI. As far as we can see, huge AI companies are currently threatening jobs with human lives with their AI models. Their goals appear to be replacing humans rather than improving them. Yeah, I mean, for the most part, I think a lot of companies are shooting towards replacing humans. And I agree with you 100% that we should use AI to improve humans. I'm actually writing a book right now on generative AI for programming. And in that book, I'm really stressing, like, you know, here's all of these different ways that people are trying to replace programmers, but we should not be replacing programmers. Instead, we should use all these tools to make programmers better at what they do, help them learn new skills. Like we'll just take Python, for example, because we're using Python here today and I'm wearing a Python shirt. So, you know, we could use AI tools to say, this is a good structured way that we know for people to learn Python. Oh, yes, I can upload the source code. I will put a link to my GitHub. And I'll upload it there right after the stream. And yes, we will make the source code available. And what I was saying is, let's say, using AI to learn Python. So we have a new person coming in that wants to learn Python. Use AI to create a structure that we know works really well for teaching people Python, the stuff that matters, the stuff that doesn't matter. Constantly tune that model, and then use AI to actually teach Like in here, I'm using Tab 9 Pro, which is an AI-based development tool. That tool will help you by suggesting things. They'll say, you're getting ready to build a loop or something like that, and it'll say, here's a better way to do this, and it suggests it. As you're doing that, that Python developer is becoming better and better. And then you get into the code review part of it, where you have code review tools that are being built with AI right now. Those code review tools are the same thing. They're going to look at my Python script here and say, hey, here's a whole bunch of things that you should fix for security or performance or something like that. That's the way I think AI should be used, and that's what I think companies should be targeting. Instead of trying to replace everybody, let's just try to make everybody better. Let's get rid of the boring stuff, lame stuff. That, in my opinion, is a lot better use. And it would be better received by people as well. Right now, there are a lot of people that hate AI with, they have a valid point if they hate AI. If it's like, hey, we're just replacing people's jobs and people need jobs. And yeah, I think using it to make people better is definitely what should be the goal. So I think I'm going to wrap up this stream, but I really want to thank everybody who's visited, all the visitors on YouTube. Really like to thank my chatters here. Fahey, am I saying that right? XLNC1807. I'd like to thank you folks for getting into the chat. Yes, ChatGPT can't do math. And that was one of the things that confused me at first when I first started using it. Like, why on earth can't ChatGPT do math? And one of the things that I discovered is how ChatGPT works, how large language models work, makes it make a little more sense. So there's not like a database in there that it's looking up. When it comes to processing numbers, it's basically processing language. And ChatGPT and other large language models are just doing predictive text. They're trying to predict what text comes next. So if you go in there and say, write me a story about a guy whose apple falls on his head, it's going to predict that and say, okay, somebody looking for a story would look for this. And it tries to predict it, and it maps it out, and it's beautiful and awesome and amazing. However, when it comes to something simple like find the square root of 4, maybe not. Maybe if it knows that all of these, 10,000 people say what's the square root of 4 and get the answer, but yeah, there's a lot of limitations to these things. ChatGPT can't do math. It can't be creative. It attempts to be creative in that it tries to mimic human beings, but it's still not as creative as a human being. So, all right. So today, like I said, we are going to go visit my friend David. He's doing a pretty cool game on Java. So he's a really good JavaScript developer. So I stream on Tuesdays. He streams on Thursdays on the Pluralsight Live channel, and I'm building a JavaScript game. So is he, but he's really good at JavaScript and a really good human being at all. I mean, I consider him a coworker and a friend. And so we're going to go visit him really quick. And like I said, thank you everybody for joining the stream, and I hope to see you next week where I'm going to make this work. Next week, I'm going to make this work. But anyway, thank you everybody for coming. And yeah, we're going to go check out, see what's going on with David. Thank you.